Okay, so this time I want to explain on the phasor. Okay, one of the method to represent a signal, we can use phasor. As I mentioned, the phasor is the most easiest method to represent a signal. Okay, because it's only require two parameters. Okay, before that, before this, I explained to you about the waveform. Okay, from the waveform we can translate to mathematical expression. Okay, so from waveform to mathematical expression, or from mathematical expression to waveform, just like this. Waveform, we can simplify the waveform using one line of equation. We can redraw it back. So if it's minus, then it starts later than 0. Okay, for phasor, so we just need these two things. The first one is the angle. Okay, so 0 will be the reference, and this is the voltage, which is the magnitude. So this is the maximum voltage, and then this is the RMS voltage. Okay, so I can give you one example here. Okay, example, if we have the theta equal to 45 degree lagging, so means that lagging is meaning that the angle can be negative, should be negative. And then if we have maximum voltage is 240 volt, and then the omega is 100 pi radian per second. So how are we going to draw a phasor? Okay, so means that we have this minus 45. So always start from 0. This is the reference, 0, our reference. So if we have negative 45, then the angle should be here, 45 degree. Yeah, so we don't have to put negative, because it's understood that if we start from here like this, the clockwise is negative. So if we draw anti-clockwise is a positive. Okay, this one, the theta would be positive. So going here, the theta would be negative. Okay, so this is the voltage is 240. So we calculate the VRMS, 240 divided by square root of 2. So it's going to be 169.71 volt. So this is the DC component, 169. Okay, so from here we can also write back the mathematical expression, because we are given this omega. So Vt equal to 240 sine. Okay, we always remember this is always sine wave. Okay, sine 100 pi t minus 45 degree. Okay, that's our mathematical expression, and then we can always draw the waveform. Okay, so we have minus 45, so minus 45 here, and the maximum voltage is 440. So the signal can be this. Okay, so we can also write the t here. T is equal to 1 over f, where the f is 1 over omega. F is omega divided by 2 pi. Okay, it's okay. So we can just omega equal to 2 pi f, and the f is omega divided by 2 pi. So we have 100 pi divided by 2 pi, and we have the frequency is, sorry, I cannot see the writing. So the frequency is 50 hertz. So the frequency is 50 hertz, then definitely the t is 1 over 50. 1 over 50 is equal to 1 over 50 is equal to 0.20 millisecond. Okay, so always remember to calculate all the parameters, so that you will not be penalized by not giving the hidden parameters. So we'll get full mark if you write this. Okay.